As we age, the brain becomes increasingly vulnerable to metabolic stress, inflammation, and oxidative damage, three interlinked processes that quietly erode cognitive function over time. While the search for neuroprotective strategies is ongoing, creatine has emerged as a promising, if underappreciated, candidate. Known primarily for its role in athletic performance, creatine's biological function in the brain is far more profound. It helps maintain cellular energy, regulates oxidative balance, and may even buffer against the damaging effects of inflammation. These functions are not merely supportive, they're essential to the brain's resilience. And in the context of aging, they become increasingly critical. At the cellular level, creatine acts as a phosphate donor to regenerate ATP, the molecule that powers virtually every biochemical reaction in the body. The brain is a voracious consumer of ATP, accounting for up to 20% of the body's energy demand despite its relatively small mass. Neurons in particular rely on consistent, rapid energy availability to sustain electrical activity, neurotransmitter recycling, and synaptic plasticity. As we age, mitochondrial efficiency declines, ATP production falters, and the brain's ability to keep up with energetic demands begins to lag. This energy shortfall has been implicated in everything from brain fog and memory lapses to the development of Alzheimer's disease and other forms of dementia. Creatine supplementation helps counter this decline by acting as an immediate energy buffer. It stores high-energy phosphate groups that can be rapidly donated to ADP to regenerate ADP during periods of high neural demand. In effect, it gives neurons a backup generator, one that becomes increasingly valuable when the primary energy system begins to falter with age. This buffering capacity is especially relevant in areas of the brain associated with memory and executive function, such as the prefrontal cortex and hippocampus, regions that are disproportionately affected by age-related decline. Beyond energy metabolism, creatine also appears to play a role in modulating oxidative stress and inflammation, both of which are central to cognitive aging. Oxidative stress refers to the accumulation of reactive oxygen species, ROS, which can damage proteins, lipids, and DNA. In the aging brain, mitochondrial dysfunction accelerates the production of ROS, creating a self-reinforcing loop of damage. Creatine has been shown in animal models and limited human studies to act as an indirect antioxidant, scavenging free radicals and reducing the activity of harmful enzymes that promote oxidative injury. While it is not a direct antioxidant like vitamin C or glutathione, its ability to support mitochondrial integrity makes it a powerful upstream defender against oxidative stress. Similarly, chronic, low-grade inflammation is now recognized as a hallmark of aging and cognitive decline. Inflammatory molecules such as cytokines and prostaglandins can disrupt synaptic function and interfere with memory formation. Creatine may reduce the production of these inflammatory mediators by stabilizing cellular membranes and supporting healthier mitochondrial function, thus addressing one of the root drivers of cognitive dysfunction, rather than merely its symptoms. There is also preliminary evidence that creatine supplementation can improve performance on tasks of working memory, reaction time, and mental fatigue in older adults, especially under conditions of stress or sleep deprivation. While these studies are relatively small and sometimes inconsistent, the pattern is suggestive. When the brain is under energetic strain, whether from age, lack of sleep, or disease, creatine may offer a measurable cognitive boost. The effects are often subtle but meaningful, particularly in maintaining clarity, focus, and speed of processing in day-to-day activities. Importantly, creatine's benefits may be amplified when combined with exercise, a known promoter of both muscle and brain health. Resistance training, in particular, has been shown to improve cognitive function in older adults, and creatine enhances the gains made from strength training by increasing muscle energy stores. The muscle-brain connection is more than metaphorical. Improved physical strength, especially in large muscle groups like the thighs, has been associated with better executive function and reduced risk of dementia. Thus, creatine may serve a dual purpose, supporting muscular health and cognitive longevity simultaneously. Of course, more research is needed. While findings to date are encouraging, especially in populations with energy deficits or early signs of cognitive decline, we still lack large-scale, long-term trials that definitively confirm creatine's neuroprotective effects in aging humans. Questions remain about optimal dosing, individual variability, and how best to combine creatine with other lifestyle interventions such as exercise, diet, and cognitive training. Some researchers are also exploring whether creatine might be more effective as a preventive strategy, rather than as a treatment once neurodegeneration has already taken hold. Still, the safety profile of creatine is exceptionally strong. It is one of the most extensively studied supplements in the world, with decades of data supporting its use in healthy adults, older populations, and even clinical settings. For most people, daily doses of 3 to 5 grams are well tolerated, with minimal side effects and no known long-term risks in healthy individuals. It's also affordable, stable, and easy to incorporate into daily routines. In summary, creatine offers more than just a performance edge. It offers metabolic protection, particularly for a brain struggling to meet its energy needs with age. By supporting ATP regeneration, buffering oxidative stress, and reducing inflammation, creatine may help preserve the brain's structural and functional integrity well into later life. While it's not a magic bullet, it is a low-risk, evidence-based intervention that deserves far more attention in conversations about aging and cognitive health. For those seeking to remain mentally sharp as the years advance, creatine may be a quiet but powerful ally in the fight against time.